All right, 4.1, video number 3. Again, angles in a plane. In this exercise, we're basically going to sketch the angles in radians. So we're used to sketching angles in degrees. So like if we had this angle here, we'd say that's 45 degrees, right? Or if we had this angle out here, from here to here, that would be 45, let's see, 45 degrees plus 90 degrees, that'd be 135 degrees. Okay, so we're used to doing that, but now what we want to do is we want to actually figure out all of the different angles using radians. And this is, in essence, the beginning of building out our unit circle. So the first thing it asks us to do is label the axis. So we're going to start here, and first axis here. This would start at 0, because that's 0 radians. It's also 0 degrees. Our next axis up here, this would be 90 degrees, but in radian, that would be pi over 2. If we wanted to, we could break out our calculator. Pi over 2 would equal 1.57 radian. And again, radian can be approximately 1.57, okay? Pi over 2 is also radian, okay? So that's just two different ways to write it. Pi over 2 would be the exact value. 1.57 is approximate. Okay, so we'll keep going over here. This is pi, which we know equals 3.14, blah, 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 blah. So it's approximate. We keep moving down to our last axis here. This would be 3 pi over 2, which is approximately 4.71 radian. Okay. So again, radians can be written using pi, the more exact or approximate. And when you get to your homework, you'll have certain times where you'll be looking at radians as just a pure number, and then other times where it's more exact, where pi comes into play. So just to kind of give you that. And let's go ahead and put these in here. So 0, oh, I'm sorry, I almost forgot. The last one, 2 pi. We have to go home. So we go all the way around our circle. We start at 0, we end at 2 pi. So pi over 2, pi, 3 pi over 2, and 2 pi. Next, it asks us to label the halfway points of each quadrant. Do that in red. That would be, there's halfway of that, the first quadrant. Oh no, come back. Here we go. Halfway of the second quadrant, halfway third quadrant, and halfway of the fourth quadrant. Okay. So the question is, what is this angle here? Okay. This is halfway between 0 and pi over 2. So this is 1/4 pi, or pi over 4. We come over here, this is halfway between 1/2 pi and pi, so that would be 3/4 pi, or 3 pi over 4. Come down here, pi. Here we have pi, then this would be 5/4 pi, or 5 pi over 4. And the last quarter here that we have, this 3 pi over 2 is the same as 6 pi over 4. So the last one here is 7 pi over 4. Okay, so label the halfway points, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And again, we say it, pi over 4, but what it really is 1/4 pi. 3 pi over 4, what that really is 3/4 pi, 5/4 pi, 7/4 pi, so 7/4 of pi. But we just, when we write it in the way we typically say it, is 7 pi over 4. Okay. All right, the next part is we're going to label the third of each quadrant. This one's a little bit more difficult. So we're going to break each quadrant. Okay, we're going to break each quadrant. Instead of breaking it in half, we're going to actually erase these, so it's a little, no, I'm not. Let me put that back in here. Let's see, pi over 4 here. Okay, so I'm going to break it into thirds, though. So now I have, there's 1/3 of the quadrant, Here is the other third of the quadrant. So when I talk, this is 1/3, right? This is a third, and this is a third. And of course, I didn't draw it very well. Each of these angles should be the same, okay? They're all 30-degree angles. But this part here, this is going to be pi over 6. It's 1/6 pi. We've divided the first quadrant into 3 pieces. The second quadrant is also 3 pieces. So if we take all of those pieces, we have 1, 2, 3, 4, 5, and 6. All right, so we're dividing between 0 and pi. We're dividing into 6 pieces. And I've got to draw this one back over here. So that's pi over 6. Over here, we would have, this would be, that's 1 pi over 6. This would be 2 pi over 6. But we are going to simplify that to be pi over 3. All right? And then at the halfway point, that would be, let's see, 1, 2, that would be 3 pi over 6, which is pi over 2. So we get over here, so that's 3. So this would be 4 pi over 6. But again, we're going to simplify that, and that's going to be 2 pi over 3. So the numbers that are in the boxes are what we will typically use. Okay, so 2 pi, keep coming around here. This is going to be 5 pi over 6. Come down here. This is 7 pi over 6. What happened to 6 pi over 6? Well, 6 pi over 6 is just pi, right? So that was that third. And then we come down here. And this is 8 pi over 6, but we reduce that down to 4 pi over 3. Almost done. 5 pi over, 8. This would be 9 pi over 4, which is 3 pi over 2. Then we have 5 pi over 3, which is the same as 10 pi over 6, just reduced down. And then our last piece here is 11 pi over 6. Okay, so again, I'll just write that's 11, or pi over 6, pi over 3, 2 pi over 3, 5 pi over 6, 7 pi over 6, 4 pi over 3, and 5 pi over 3, and lastly 11 pi over 6. Okay? So however you need to memorize that, or remember, hopefully you can either build it using your fractions if you're good with your fractions. Otherwise, you just have to kind of remember where those all are. All right. So 2 questions here. Where are the acute angles? Well, let's clean this up. Where would our acute angles be? Well, again, an acute angle is between 0 and 90 degrees, or between 0 and pi over 2. So any angle here, right, is going to be acute. So that would be in the first quadrant. That's if it is a positive angle. But we also have negative angles. So we could also, same initial point, but we could also have it somewhere down here. This would be our negative angle. All right, so we could find that's our fourth quadrant. So where do we find acute angles? We find it in the first quadrant and in the fourth quadrant. Okay. Obtuse angles are between 90 and 100 degrees. So I'm going to draw an obtuse angle here within my circle. There's my obtuse angle. And we find our obtuse angle, okay, greater than 90, less than 180. We find that in the third quadrant. And again, that's a positive angle. And we can also have an obtuse negative angle where we go clockwise. Looks something like this. we go clockwise. That's our negative angle, a negative obtuse angle, and that's in the third quadrant. Did I say second? I might have made a mistake. This is our second quadrant. Okay, so second and third. So where are the obtuse angles? In the second and third quadrant. How can you calculate coterminal angles in terms of radians? We have to remember what a coterminal angle is. It's basically if we have, right, we have this angle here, okay? The coterminal angle has the same initial side, but it's going to come all the way around and end at the same place. So in that case, we would take the measure of our angle theta and we would add 2 pi. It asks for it in radians. If we were doing it in degrees, it would be our angle plus 360 degrees. Now that's if it's a positive angle, but remember we can also have negative angles. So we could also take our angle and we can subtract 2 pi or take our angle and subtract 360 degrees. Okay, so to calculate a coterminal angle, once you have that angle, you either add or subtract 360 or add or subtract 2 pi, depending on if it's in radians. Oops, bigger. This is radians, and this is degrees. Okay, so add or subtract 360 degrees, add or subtract 2 pi. How do you find complementary and supplementary angles in radian? All right, if it's complementary angles are less than 90 degrees, but we're dealing in radian, 90 degrees equals pi over 2. So you would take pi over 2 minus whatever this angle is. And then if it's supplementary, all right, that would be less than between 180 degrees and 90. So we would take 180 degrees, or since it asks in radians, 180 degrees is pi. So this would be pi minus whatever that angle is to find our supplementary. Okay. So just very quickly take a look. It wants us to graph these angles. Let's remind ourselves this is 0. This is pi over 2. This is pi. 3 pi over 2. 2 pi. So I want an angle that is 3 pi over 2 in radians. So my initial side starts at the positive x-axis, and then I go around here until I get to 3 pi over 2. So this would be my theta, the measure of my angle. Okay, 11 pi over 3. Well, if I go all the way around the circle, that's 2 pi, and if it's thirds, so think about this, 2 pi equals, 6 pi over 3. So if I took 11 pi over 3 minus 6 pi over 3, that gives me 5 pi over 3. So if I'm drawing this angle, I'm going to basically take 11 pi over 3 equals 2 pi plus 5 pi over 3. So I go all the way around. There's my 2 pi. And then I need to go another 5 pi over 3, which is clear around here. And that's what my angle would look like. So that's my theta. Lastly, my angle, the measure of my angle is -1/4. So again, I start with my initial side. It's negative, so I'm going to go clockwise, pi over 4. And we know that pi over 4 is halfway, 1/4 pi is halfway between 0 and this 1/2. So that would be my theta equals negative pi over 4. Okay, lastly, graph 2 pi over 5. Well, where would 2 pi over 5 be? Well, this up here, this is pi over 2 written in fifths. Let's see if I multiply it. Let's see, 2 pi over 5. What's a good way to, well, it's going to come in here. Here's my initial. And it's going to look something like this. This is theta equals 2 pi over 5. What does it want? It wants to find a coterminal angle. So coterminal angle would be to take coterminal. We said if we take to get a coterminal angle, we're going to take our angle and we're going to add or subtract 2 pi. So 2 pi over 5 plus, how would we write 2 pi in fifths? That would be 10 pi over 5. 10 pi over 5 equals 2 pi. So if I add those together, I get 12 pi over 5. I could also take 2 pi over 5 and get a negative coterminal angle. So this is positive. Negative would be to subtract 10 pi over 5. That would give me negative 8 pi over 5. So those are two coterminal angles, a positive one and a negative one. It then wants a complementary angle. Triangle. Complementary, we take pi over 2 minus our angle, 2 pi over 5. All right, we're subtracting fractions here, so we need to get a common denominator. This would be 5 pi over 10 minus 4 pi over 10 equals pi over 10. So if our angle is 2 pi over 5, the complementary angle to it, what would add up to equal pi over 2 or at 90 degrees would be pi over 10. And then lastly, supplementary. Here we'll take pi minus 2 pi over 5. Again, common denominator, that'd be 5 pi over 5 minus 2 pi over 5, 3 pi over 5. And that makes sense. 3 pi over 5 plus 2 pi over 5 equals 5 pi over 5 equals pi, which equals 180 degrees. Going back up here really quickly, if I took my 2 pi over 5 plus pi over 10, common denominator, that would be 4 pi over 10 plus pi over 10. That equals 5 pi over 10, which equals pi over 2, which equals 90 degrees. All right, that's all she wrote. Oh, let's see. I think last thing I didn't really touch on there, but I know it's going to come in the homework, so very quickly. When we look at our, maybe I did talk about it. Oh, I think I did, yeah. Pi over 2, that's pi over 2 radian. It can also be written as approximately 1.57 radians. Okay, I think I did touch on that, all right? So that just comes up in the homework. So being able, these are both radian measure, it's just this is exact and this is an approximation. All right.